complex equations are equations that contain complex numbers. When we are solving a complex equation, we might be looking for an unknown in the equation, maybe an unknown x or an unknown y or any other variable that we may look for. The approach that we take when we are solving complex equations, we reason that if two complex numbers are equal, their real parts should be equal and their imaginary parts should also be equal. So in most cases, what we do, we go to the left-hand side of our equation and manipulate it to be in the standard form of a complex number. Then we also go to the right-hand side of our equation and we manipulate it to be in the standard form of a complex number. Then we conclude that the real parts are equal, which means we're going to equate the real parts on the left-hand side and what we have on the right-hand side. Then we go ahead also to equate the imaginary parts on the left-hand side and the imaginary parts on the right-hand side. Maybe I should explain it better, or I can explain it better using the example that I have. We have here, they want us to solve for x and y in this equation. If you look on the left-hand side, we already have a complex number in standard form. And here, this is the real part of this complex number, and this is the imaginary part on the left-hand side. If we go to the right-hand side, we also have a complex number in its standard form, which by that I mean a plus bi, and 4 is representing the real part of this equation, of this complex number, and the 3, or this 3i here, it is representing the imaginary part of this complex number on the right hand side. Because we have an equal sign here, we have to conclude that the two complex numbers on the left hand side and the right hand side, they are identical, or they are equal. And for them to be equal, their real parts have to be equal and their imaginary parts have to be equal. This is how we solve for x and y. I hope I'm quite clear here. Let me rewrite this. We have 2x minus I. So this is 2x minus iy being equals to 4 plus 3i. 4 plus 3i. I'm going to the solution here. The approach is first simplify left hand side. So simplify RHS and LHS to standard form. By this I mean z equals to a plus bi. You go to your left hand side and you go to your right hand side, you simplify what you have there to standard form, then equate the real parts also equate the imaginary part. They should be equal. If you have an equal sign in between, it means they should be equal to equate imaginary parts. And after you do the equating, then you can solve for the unknown. Okay, in our example here, it means therefore 2x should be equals to 4. I am equating here the real part. The real part on the left hand side is 2x, on the right hand side it is 4. From here now I can solve for my x. Therefore x is equals to a positive 2. This is my x. Done. I equate also the imaginary parts, which means minus y should be equals to positive 3. From here, I can conclude that y is equals to minus 3. This was quite straightforward because the question that I was given was already in standard form. It was already simplified in standard form, both the left hand side and the right hand side. But if you're not given a question that is simplified, or that is not in standard form, you have to do some work and convert it to standard form. I'm going to give another example here. Let us say this is example number 2. So the example number 2 is solve for x and y. Again, solve for x and y. Solve for x and y. We have 2x. The original one is 2x plus 2y plus ix plus I, then x here. They say this is equals to 4i. All right, I want to have an imaginary part and a real part, both sides of this equation. That is going to be my approach. So I'm going to take the 2y, because this 2y is a real number. I'm going to take it to the right hand side. So I have 2x I'm going to have here 2x plus ix. This is equals to 2y. No, not 2y. It's going to be minus 2y, because I took it from the right hand side. Now from the left hand side to the right hand side, it's minus 2y plus 4i. Whatever I have here, we said it is equal. What I have on the left hand side is the standard form of, this is the standard, on the left hand side I have a standard form of a complex number, and on the right hand side I also have a standard form of a complex number. From here it means 2x is equals to minus 2y, which we can reduce to x is equals to minus y. X is equals to minus y. Let us call this equation 1. Then let us go to equation 2. So what I'm doing here on the left hand part, this is the real parts. These are the real parts that I'm equating. I'm going to do this question again in another way, but still we should get the same answer. Then I go to equate the imaginary parts. Imaginary. On the left hand side, the imaginary is a positive x. And on the right hand side, the imaginary is a positive 4. Which means x is equals to 4. So we have solved for our x. If we want to solve for the y, we come back here to equation 1 and substitute x. So we have 4 equals to minus y. This means, therefore, y is equals to minus 4. This is the solution of the equation. Y is equals to minus 4 and x is equals to 4. All right, let us try to do the equation in another way. Let's see what we get. I'm going to write the equation in another format, or I'm going to approach this equation in another way. Let me rub out this and do the same question using a different approach. Okay, I'm going to take this 4y. I'm going to take the 4y here to the left hand side, and I take the 4i to the left hand side. Then I take 2y and ix to the left hand side. I can do that. All right, so I have here, I'm just rearranging. Let me rearrange it. This will be 2x minus 4i. This should be equals to, I'm sorry, there's a plus sign here in the middle. So So this is plus here. There's a plus here, please. There's a plus. I'm going to take the 2y and the ix to the right hand side. So this is equals to 2y, which becomes a minus 2y, by the way. This is minus 2y and equals to minus ix. Like this. Now I can equate the real parts and I also equate the imaginary parts. From here, we know that 2x should be equals to minus 2y, which means x is equals to, from here it means x is equals to minus y. See? Same approach. And y is equals to minus x. Same approach. Now, the other part, I'm going to equate now the imaginary parts. This means minus 4 is equals to minus x. Therefore, x is equals to 4. Once we know our x, it means we know our y, and therefore our 4 is equals to minus y, which means therefore y is equals to minus 4. So both ways, no matter which way you use, you should get the same answer. X is 4 and y is minus 4. This is how we solve the complex numbers, the equations of complex numbers. I'm going to try one more example that is a bit complex. This example is just going to be a bit complex. We're going to solve for x and y once again, but we have 3 plus 2j, or let's use 2i. This 3 plus 2i is multiplying minus 6 minus I. We close the bracket. This is equals to x plus jy, x plus jy, which I'm going to write is x plus I, y. This is multiplying minus 2 plus 4i. So this is minus 2 plus 4i. We are required to solve this complex equation. It is a complex equation because it is an equation involving complex numbers. We're looking for our x and our y. The approach here is to simplify both sides of our equation so that they go into standard form. Z equals to a plus bi. That is what we do. We're just going to do the multiplication of complex numbers and simplify. 3 times minus 6, we get minus 18. So this is minus 18. 3 times minus I, we get minus 3i. Minus 12i. Then minus 2i squared, minus 2i squared. This should be equals to x times minus 2, we get minus 2x plus 4ix. And then minus here, minus 2iy, and then we have plus 4, so it's 4i squared y. Okay, let us check if we have done everything properly. The multiplication, we're simply using the FOIL method here. Okay, let us simplify. On the left hand side, we have here minus 18 minus 15i, then minus 2i squared is actually plus 2. Because I squared is minus 1, we remember this, that I squared is minus 1, so times the minus 2, we get a positive 2. On the right hand side, I'm just going to group together real terms. This is going to be real because I squared is minus 1. So this 4i squared, y is just going to be minus 4y. So I'm going to take minus 2x minus 4y. this part here is real, what I've just written here. Then I go to the imaginary part, which is plus 4ix minus 2iy. This is what I have. So on the left, on the right hand side, this is real, and this is imaginary. So this is real, this is imaginary. And let me complete this. Now, minus 18 plus 2, because I can add them together since they are all real numbers. Minus 18 plus 2, I get minus 16. So this is minus 16 minus 15i. I have simplified completely the left hand side. Then the right hand side, I'm just going to do, I'm just going to combine them together, just the combination somehow into brackets for some reason. I'm doing this for a reason. So 2x minus 4y. I'm going to put this in bracket because this is the real part of the right hand side. Then on the left hand side, I'm going to take out my I. So this is going to be plus. Then I put I here outside. In brackets, I have 4x minus 2y. So I have the real part of the left hand side, and I also have the real part of the right hand side. From the left hand side, we have minus 16 for the real part, and on the right hand side, we have minus 2x minus 4y. So we can equate this part. So we have minus 2x minus 4y should be equals to minus 16. So this is equals to minus 16. Let us call this equation 1. And then we can also say 4x minus 2y should be equals to minus 15. We call this equation 2. Because we have two unknowns and we have two equations, we can solve these two equations simultaneously using all the methods that we know about solving simultaneous equations. I'm going to solve these equations simultaneously. We can use the method of elimination, or we can use the method of substitution to solve these equations. I'm going to use the method of substitution. I want to use the method of substitution to solve these two equations simultaneously. So I'm going to rewrite the equation as minus 2x minus 4y, minus 2x minus 4y is equals to minus 16. I can divide throughout here by minus 2. You can divide by minus 2 throughout. If you do that, if you divide by minus 2 throughout, you're going to get x plus 2y equals to 8. Let's call this equation 3. Then I have my equation 2. My equation 2 was just 4x minus 2y. So 4x minus 2y equals to minus 15. This was my equation 2. From equation 3, I can solve for x. From equation 3 here, I can conclude that x is equals to 8 minus 2y. Let us call this equation 4. I'm going to substitute equation 4 into equation 2 so that I eliminate x. So this is like 4 times 8 minus 2y minus 2y equals to minus 15. From here we got 4 times 8, that is 32. 32 minus 8y minus 2y equals to minus 15. I'm going to group the like terms. So the 15 is going to come this side. So it's going to be 47. So we have 32 plus 15. The answer is 47. So we have 47 being equals to minus 8y minus 2y. This becomes a 10 minus 10. So and we're going to take it to the other side. So it's going to be 10y this side. So we have 10y. From here, we can conclude that therefore y is equal to 4.7. 4.7 is our y. And if we go to equation, we substitute this into equation 4, x is equals to 8 minus 2y. And now we know our y. We know that our y is 4.7, so this is like x equals to 8 minus 2 times 4.7. We punch in our calculator, we get our x as 8 minus 2 times 4.7. We get minus 1.4, so x is minus 1.4. You have to solve for your x and your y. So what did we do here? We simplified the left-hand side into the standard form of a complex number, and then we went to the right-hand side. We also simplified it into the standard form of a complex number. Then we had to equate the real parts. The real part on the left-hand side is equal to the real part on the right-hand side. Then the imaginary part on the left-hand side is equal to the imaginary part on the right-hand side. If they are, then you have equations that you can solve. If they are simultaneous equations, you can solve them simultaneously, and you get your missing variables, or the unknowns as it were. All right, I hope this is clear and you have learned clearly what you had to learn. I don't see any mistake in this question. I don't see any mistake. Everything is quite clear. If you have any question or any problem with anything, just let me know. I will respond to you. Otherwise, thanks for watching the video.